Okay, so the key is to remember that any inverse function has to have, for a function to have an inverse, it has to be a one-to-one function, doesn't it? Which is the restriction that we've made here. So that's the restriction we decide for sine x. Okay, so the function is one-to-one there between negative pi on 2 and pi on 2, which means my inverse function, which is, I guess, the equivalent of saying in some respects, that x is equal to sine y. It's almost like having, if we turn our graph the other way around, it's my sine graph about the y-axis instead, isn't it? So that's where our inverse, sine inverse graph comes from. Now remember that the domain of the inverse is the range of the function, etc., etc. So that gives us these little facts. The domain of sine inverse is equal to the range of sine, which is negative 1 to 1, and the range of sine inverse is the domain of the original, which is negative pi on 2 to pi on 2. A couple of things to remember, that if we take the function of the inverse, so f of f inverse is just equal to x. All right, so that's our basic shape of our graph. Cos inverse is the same. The only difference being is that the domain that we restricted to make it one-to-one is from 0 to pi. Yeah, the range is still negative 1 to 1. So the graph that we're looking for here, same sort of thing. If I was to flip it upside down, there's my cosine graph about the y-axis. So we get that section there of the graph. And again, the domain of the inverse is equal to the range of the original. And the range of the inverse is the domain of the original. A tan inverse graph, similar properties. So it's a reflection about the line y equals x. So I guess the easiest way I think to remember it is my vertical asymptotes on my original graph become horizontal asymptotes on the inverse. So there now we have a range of the graph bound between negative pi on 2 and pi on 2. And the range of that, the domain of that graph, you can see it just extends on and on. So the domain is R, and the range is between negative pi on 2 and pi on 2. All right, so again, there's just those key points there. The domain and the range of the graph that we're interested in. Obviously, we can only evaluate an inverse trig function if the domain of the value or the x value itself is within the required domain. So there's my standard ones. Obviously, something like this is undefined because there is no angle that gives me a sine value of 1.2 or a cos value of 2. All right, so let's have a look at a bit of a graph sketching. So I reckon the first thing really is let's concentrate on the domain of my graph. We know that the domain of cos inverse is negative 1 is less than x, which is less than 1. So in this case, I need 2 minus 3x to be less than 1. So if we subtract 2 from both sides, so minus 3, negative 3x, which is less than minus 1. Divide by negative 3, so we end up with 2/3 is greater than x, greater than 1/3. So now all of a sudden we can see that the domain of my graph is between 1/3 and 2/3. So if we consider that graph a bit more specifically, let's rewrite it. Cos inverse of, it's negative 3 at the front, that'll give me a positive x minus 2/3. So we have reflection. It's about the y-axis, isn't it? Because it's inside the function. We have a dilation by 1/3 from y-axis. And then we also have the translation of 2/3 to the right. So if let's do 3 separate little graphs here just to practice our transformations. Original graph, let's put it in. So we've got 1, -1, 0 to pi. And if we reflect that about the y-axis, first thing I'm going to do is go something like that, still at -1 to 1. Dilate by a factor of 1/3 from the y. What does that mean? Everything gets squashed up by 1/3. So that makes that -1/3, and that's +1/3. And we're still up here at pi. And then we're translation of 1/3 units, sorry, 2/3. Can't read my writing. Translate 2/3 of it to the right, which means then that point at -1/3 comes out there. So that point there becomes +1/3. That point there becomes +1. That's still at pi. So the good thing about doing this like this is I'm thinking that my domain is between 1/3 and 1. So let's come back over here. What's happened here? So over here we subtract 2. So that should be a -3 there and a -1. So that becomes 3/3. So that corresponds in, doesn't it? So the domain of that graph, sketch the graph over the maximal domain. So we don't have to sketch it, state it, but we will. The domain of that graph is from 1/3 to 1. So the graph and the algebra, if you like, both correspond in the end. So nearly a bad mistake then. All right, what have we got there? We've got a little bit less in the way of transformations. We've got 2 units left, and we have pi on 2 units up. So if we do a quick sketch of my original, I've got asymptote there, and the graph is looking that way. And that's pi on 2, negative pi on 2. So straight away, the pi on 2 up really makes those asymptotes fairly quick to resketch. So let's just put them there. Put that there. So I'm going to put 0 to pi. And my graph is going to go 2 units to the left. So that point there, that would be in the middle, is now going to be there. So the graph's going to look a bit like that. Does it say anything about having to find? We don't have to find intercepts. So the domain is still going to be R, but the range in this case will be 0 to pi. I guess the y-intercept, put x equal to 0. So the y-intercept will simply be tan inverse of 2 plus pi on 2, whatever that comes to. All right, find the implied domain and range of. Let's work through a couple of these. So again, so what's my standard sine graph? Its normal domain is -1 is less than or equal to x, which is less than or equal to 1. So 2x plus 1. So subtract 1 from both sides. -2 is less than or equal to 2x, which is less than or equal to 0. Divide by 2, we get -1 is less than x, which is less than 0. So a domain of -2 to 0. And the range hasn't changed. So my range is still for my sine graph is going to be from negative pi on 2 to pi on 2. Don't forget that information there in black and that information there is on our formula sheet. All right, so my range for cos is normally from 0 to pi. Since I'm going to multiply it by 2, it becomes 0 to 2 pi. My domain, negative 1, is less than or equal to 3 minus 2x, which is less than or equal to 1. Subtract 3 from both sides. So running out of room. So subtract 3, we get negative 4 is less than negative 2x, which is less than negative 2. Divide by negative 2, I get 2 is greater than x, which is greater than 1. So that makes my domain then bound between 1 and 2. All right. Let's try these VCAR questions. Rule with the equation blah blah has its maximal domain and A, B, and C are positive constants. It has no x-intercepts if. Well, let's think about the tan inverse graph. There and there. So A is increases the magnitude, doesn't it? So normally those points there are pi on 2 and negative pi on 2. So they're now going to become pi A on 2, negative pi A on 2. So has its maximal domain. So the B value, all the B value is going to do is shift it left and right, so that's not really relevant. So the plus C is, we're going to assume it's a positive constant, so we're shifting the whole graph up. So we're going to shift the whole thing up. So my asymptote is going to be at C minus pi A on 2. So this will have no x-intercept, so we need the C value has to be greater than pi A on 2. So that means if we manipulate for, oh, well, there's just a C there. Hopefully that's there somewhere. Has no x-intercepts if C is, oh, there we go, E. We can have greater than or equal to, because if it's equal to, it means the asymptote is going to be on the axis line. And so that's fine. All right. Blah, blah, has an implied domain given by, again, the C value is not relevant, but I do need, so the domain normally for sine is negative 1 is less than or equal to AX minus pi, which is less than or equal to 1. So we need to add pi. So I get pi minus 1 is less than or equal to AX, which is less than or 1 plus pi. A must be greater than 0, it is. So we get pi minus 1 on A less than X less than 1 plus pi on A. Hopefully that looks like one of them. Pi minus 1 to pi plus 1. That one there looks about right. It's definitely pi minus 1. Square bracket, so that's okay. Yeah, I'm pretty comfortable with that answer. 3C, off you go.